So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to see the third problem related to recursion, that how to check whether the string is palindrome or not. I believe that you guys already know that what is palindrome. We can say a word is palindrome when we read the word from left side as well as right side, it should be same. So let's take one word as racecar. Okay, so if we read this word from the left side as well as from the right side, okay, we are getting the same word. So this word can be said as a palindrome. Okay, now since we are learning the recursion, okay, so in the previous lecture I might have told you that every recursive program can be programmed in an iterative approach as well. Okay, so let's first see that how we can solve this problem using an iterative version. So iterative approach. So here in this case, let's take this word only, race car. Okay, now this word is actually stored in a variable, let's say str. Now what I'll do, I'll actually make one more variable, let's say str1. Okay, and then I will be starting to store all these letters of str inside this str1 in a reverse order. So starting with the last letter. So if I store this, it will be R A C E C A R. After that, I will be checking whether these two words are equal or not. If they are, then I will be returning true or else false. Okay, so this will be the idea of the first approach. Now the thing is that in Java we know that the strings are immutable, right? We can't simply create this str1, okay, and start putting letters one by one, right? So here I'm going to take the help of string builder. Okay, so here first let's create the string builder. SB equals to new string builder. Okay, and after that, using the for loop, whether I will be coming from n minus 1, I should be greater than 0, I minus minus. Now inside this I'm going to first extract the last character. So char ch equals to str1 character at I. So this will be extracting the last character one by one. Okay, starting with R, then A, then C, and so on. Okay, after that I will be having sb dot append. After extracting every character from the right side, okay, it will be starting to store in this sb and ch. That's it, and then returning while checking whether sb dot to string, because we are comparing two strings. Okay, the str is actually a string, but here I have taken the help of sb, that is a string builder, which is not a string. Okay, so I will be converting this sb to the string, so to string dot equals str. So this method dot equal will be returning true if they are equal, otherwise false. So in this way we can solve this approach. We can solve this problem using the first iterative approach. There is another approach as well. Okay, let's see that. Let's take same example. Okay, now here I will be taking the help of two pointer technique, such that one variable will be pointing to the left corner of the letter and the one will be pointing to the right corner of the letter. Now I'm going to check whether these two letters are equals to or not. If they are equal, okay, then I will be shifting this L and R. Okay, so L will be plus plus and R will be minus minus. Now again I will be checking whether these two letters are equal or not. Okay, here I can see that they are equal. So again I will be moving this L to the right side and R towards the left side. Again check whether these two letters are equal. Yes, they are equal. Okay, so move it. So L will be gone to the left side and R will be going to the right side. Okay, now again I'll check. Here I can see that E is equal, right? L is pointing to E and R is also pointing to E. They are both equal. Okay, again I will be going to move forward. So L will be going to the right side and R will be going to the left side. Now here this is the condition. If L is lesser than equals to R, I will be moving forward. If they are not, okay, then I will be stopping it. Okay, I will be terminating it. So in this way also we can check whether the string is palindrome or not. So the pseudocode will be looking like this. Initially L will be 0, R will be n minus 1. N is nothing but the length of the string. Using the while loop, whether L should be lesser than equals to R. Okay, if it is, then char ch, let's try to extract the left character and right character one by one. So char left character equals to str dot character at left. Again char right character equals to str dot character at R. Okay, so left character and right character has the letters from both the end. Okay, now I will be going to check if left character is equals to, sorry, it's not, if it is not equals to right character. If they are not equal, then it simply means that from both the ends the letters are not equal, so simply return false. Okay, but let's say if we are not going inside the if statement, okay, that means the left character and the right character are equal, right? So we have to move the left pointer and the right pointer. So the left pointer will be moving to the right hand side, so L plus plus, and the right pointer will be moving to the left hand side, so R minus minus, and that's it. And if we don't go inside this if statement, that means all the letters are equal, that means the word is palindrome, so at last return true. I hope you got this. If you didn't, I recommend you to please try it by yourself. So these are the two iterative approach. You can go by any of them. But if you talk about the time complexity, okay, here we can see that the for loop is running for n time. So the time complexity will be simply order of n. And what about the space complexity? Here we can see that we have taken the extra space by creating the string builder. Okay, so here the space complexity will be order of n. But if you talk about the second approach, here we do see that there is a while loop. Okay, so the L pointer is coming from the extreme left side, okay, and going to the right hand side, and the R pointer is coming from the extreme right side and going to the left side. Okay, so they will be stopping in the middle only. Okay, so due to that we can see that the while loop will be running for n by 2 times, so the time complexity will be order of n only. Okay, and here we didn't take any extra space, right? So the time, sorry, so the space complexity will be constant, that is order of 1. Okay, so if you see, the second approach is much optimized one than the first. Okay, so you can use this. Now let's see that how we can try to design a recursive approach. Okay, so I will be showing the recursive approach using this idea only. Okay, now the thing is that let me give the idea here. There is a race car. Okay, now L is pointing to here, R is pointing to here. Okay, if they are equal, then I will be passing this word race car, okay, to the next function. Okay, but the L will be different and the R will be different. Basically, the L will be moving forward and the R will be moving to the right hand side, to the left hand side. Okay, so now in the second function, the L will be pointing here and the R will be pointing here. If they are again equal, then again I will be passing the word race car. Okay, but now here L will be pointing to this C and R will be pointing to this C. Okay, if they are again equal, then I will be moving this, I will be passing this race car, and the value of L and R will be different again. Okay, so let's see this boolean. Let's name the function as pally, in which I will be passing I will be passing the string, the L and the R. Initially, when the function calling is coming from the main. Okay, so here in this case, the value of L will be 0 and value of R will be n minus 1 initially. Okay, after that I will be checking if L is greater than equals to R. Okay, here in this case we have passed this, so I'm talking about this when L is pointing to here and R is also pointing to here. Okay, so it means that we have completely checked all the letters one by one. Okay, and then now we have reached here. Okay, if we have reached here, that means this letters and this letters are basically same. Okay, so due to that reason I'm just returning true. Okay, but here we can see that it is a odd length character. Okay, but let's take as even letter character. A, B, C, sorry. Okay, here we can see that it is a palindrome, right? So L is pointing to here, R is pointing to here, then L will be pointing to here, R will be pointing to here, right? Now L will be pointing to here and R will be pointing to here, right? So here we can see that the L is actually greater than R. Okay, so due to that reason, I'm combining these two. So if L is greater than equals to R, then I'm going to stop it. So if this is the case, then simply return true. Okay, now if this will be the anchor condition. Okay, now I'm going to extract the left character, that will be str dot char at left, then right character equals to str dot char at r. Now I'm going to check if left character is not equals to. If it is not equals to, then I'm going to return false. Otherwise, if they are equal, then I need to pass the string by moving the left pointer and the right pointer. So return pally by passing the string. Okay, then L plus 1 and R minus 1. That's it. I hope you got this. So in this way, the recursion is happening to find a palindrome. Okay, so I hope you got this. If you didn't, I advise you to please try run it by yourself. Okay, so that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you.